If you park your car on certain mountain roads and put it in neutral, it will slowly roll backward, straight up the incline. Pour water onto the asphalt, and the stream will climb the hill right alongside you. This occurs at dozens of sites globally, including the approach to Mount Ararat and Mount Aragats in Armenia. Here, visitors regularly document streams that appear to flow from the bottom of the valley toward the distant peaks. At first glance, this looks like a localized breakdown of gravity, but the reality is a visual system misinterpreting geometry. This diagram breaks down the illusion. Without a clear horizon line to ground our perspective, surrounding angled hillsides feed our eyes incorrect reference points. Our brains calculate the incline incorrectly, making the true downward slope register as a steep uphill climb. The water here is strictly obeying gravity, even if our eyes suggest otherwise. However, under specific physical constraints, natural forces can overpower the local gravitational gradient and physically drive water upward. To find water physically moving up an incline, we have to look beneath the ice sheet of Antarctica, specifically near the buried Uinta Mountains. Deep below the frozen surface, radar sweeps have mapped a subglacial river system. The water in this buried network is flowing backward, uphill, against the natural flow of the ice sheet above it. The weight of millions of tons of glacial ice bearing down creates intense hydraulic pressure. Like a boot stepping on toothpaste, the sheer downward pressure squeezes the liquid water backward, driving it up the rocky incline against standard downhill flow. This same physical pressure occurs in tidal rivers like the River Severn. Surging ocean tides funnel into the estuary, creating a tidal bore that reverses the river's current and forces it miles upstream. Massive pressure and tidal momentum can shove water backward in the short term, but to lock an uphill river into the surface of the Earth permanently, you need the machinery of deep time. The Green River in the American West presents a unique geographic problem. It winds through flat valleys before colliding with the 4-kilometer-high Uinta Mountains. Looking at this topographical map, the route is paradoxical. Instead of going around, the Green River cuts a deep canyon straight through the solid rock of the highest peaks. It creates the geographic impression that the river is carving its way up into the mountains. Explorer John Wesley Powell documented this during his 1869 expedition, realizing the water had somehow bypassed the towering topography surrounding it. For over a century, geologists debated two theories: antecedent valleys, where the river maintained its course while the mountains rose, or superposed valleys, where the river flowed over flat sediment that was later eroded away. Seismic imaging reveals the actual sequence. The river follows the path of a landscape that was physically pulled out of alignment by forces deep underground. In 2026, a research team led by Adam Smith used deep earth modeling to scan the mantle beneath the canyon. They found the mechanism that allowed the Green River to cross the range. This models a lithospheric drip. Dense material pooled beneath the crust. Sinking into the mantle, it dragged the surface downward. The mountain sagged, creating a low path for the river. When the mass detached, the crust rebounded, raising the mountains around the locked river channel. The water was never flowing uphill. The mountain surface sank, the river crossed a temporary valley, and the earth bounced back. Apparent uphill flow occurs when an external variable overpowers the local pull of gravity. We have seen this range from missing horizon lines that trick our perspective, to millions of tons of glacial ice driving water through rock, to deep earth drips that relocate entire mountain ranges. Ultimately, the laws of physics are absolute, but the Earth is dynamic enough to hide those rules behind massive processes happening on a scale we rarely see. When we find a piece of nature that seems impossible, it means we haven't pulled back far enough to see the forces driving the process.